Hello, welcome back. In this video, we're going to practice the logarithmic differentiation rule. And for this purpose, we have two ln functions provided, natural logarithmic functions provided to us. One comes with the square root, but the other one comes with the absolute value for the inner function. And here are the rules to find the derivatives of ln functions. If the given function is just simply ln x, then the derivative of that is just 1 over x. And if the given function is ln of a function where u is a function of x, which is differentiable, so the derivative of ln of u is going to be 1 over u times the derivative of u with respect to x. In other words, u prime divided by u. So let's practice this rule for the given function. Well, first off, this is not ln x, so we just don't use this rule. Instead, we use ln of u rule here, where for this function, u is square root of x squared minus 4. F of u is just ln u. Okay? And in the formula, we need u prime. So first, we're going to find u prime here. And we're going to use the chain rule or general power rule for this one. So essentially, I'm going to write this as the 1/2 power of x squared minus 4. And the general power rule says that this is equal to the derivative of the outer function is 1/2 to the power of 1/2 minus 1, and then I'm going to write exactly the same thing here, x squared minus 4. And we're going to multiply this by the derivative of the inner function, which is the derivative of x squared minus 4. So this rule, in short, called chain rule. A chain rule is sort of like the generalization of the rule that we derived earlier. That rule was the derivatives of the composite functions. Okay. All right, let's simplify this term here. So this is 1/2. So this becomes negative 1/2. So I'm going to write it as a reciprocal. So it's going to be 1 over x squared minus 4 to the power of 1/2, which is the square root of x squared minus 4. We generally don't carry forward the powers like this, and if you can write this term in this form at the end, that's always better in terms of the look, times the derivative of x squared minus 4. We're going to use the power rule for the inside. So the derivative of x squared is 2 times x. The derivative of constant is 0, so the derivative of this is just 2x. Let me just write that here. 2, since we're multiplying, so it's 2x over root x squared minus 4. All right, so the derivative of u is given in this form. And now we're just using this formula here for this u prime and for this u here. So in other words, f prime is equal to u prime over u, square root of x squared minus 4. Okay, a quotient dividing a piece here. So I'm going to make it look like a quotient. And I'm going to flip this over. So in the bottom, you have two square root functions having the same inner parts. So this is equal to x over x squared minus 4. Let's move to part B. For part B, we're going to use another formula that we have in our lecture notes. So this derivative is equal to u prime of u. So essentially, this is not really different from what we had in part A. The formula works exactly the same way. All we need to do is just to have the right labeling. So let's start. All I need is to label u. And in this problem, u is inside of the absolute value. So in other words, it is equal to, so this is u, so u of x is equal to cosecant of x. And in this formula here, I only need u prime. All right, so u prime is in fact the derivative of cosecant x, and you can read this out from the table for the derivatives. So that is minus cosecant x cotangent x. And using this formula, g prime of x, which is the derivative of ln of the absolute value of cosecant x, is u prime over u. Let's just write it down. U prime is minus cosecant x and cotangent x divided by u is cosecant x. And the good news is that there's a cancellation here. We divide the top and the bottom out by cosecant x. So the result is negative cotangent x, which is the derivative of ln cosecant of x in the absolute value. All right, thanks for watching. I'll see you in another video. Bye.